So today we're going to take a look at how to work with applications or word problems involving trig. Most of this should be familiar to you. You should have seen it in geometry and probably a little bit in algebra 2 as well. So we're going to start with a review of what it means to solve a right triangle. And all that means is to find all of the missing information about the right triangle, all of the angles and all of the sides. So when we're looking at our triangle, we're given one of the angles. So to solve for the missing angle, we know that 90 degrees is already taken up with that right angle. So the other 90 degrees for the full 180 in a triangle is for the two acute angles, angles B and A. So we're going to take 90 degrees and subtract the measure of angle A to get the measure of angle B. So the measure of angle B is 55.8 degrees. To solve for the missing sides, you use SOHCAHTOA. I'm going to use angle A because that's the one labeled in the picture. So to solve for side A, we're going to use the tangent because we're looking for the opposite and we know the adjacent. So the tangent of angle A equals opposite over adjacent. So to solve for A, we're going to multiply both sides by 19.4. Make sure that your calculator is in degree mode. If your calculator is in radian mode, you will get a way wrong answer. So if you want to double check, for A, I got 13.184. If you do not get that, you're probably in the wrong mode. And lastly, we're going to solve for C. Again, I'm going to go back to angle A. This time I have the adjacent and I'm looking for the hypotenuse. So I will use cosine of 34.2 equals adjacent over hypotenuse, multiplying both sides by C, and dividing by cosine of 34.2. We have 19.4 over cosine of 34.2. So our C value is about 23.456. For our first application question, we have an example about the maximum safe angle of elevation for a rescue ladder for a fire department. So I'm going to sketch a little picture here. So we've got that 72-degree angle of elevation. Remember, an angle of elevation starts with a horizontal line and a line of sight up. The ladder itself is 110 feet, so that'll be our hypotenuse. And the question is, what's the maximum safe rescue height? So that's going to be our vertical side. We have the hypotenuse. We're looking for the opposite, so we're going to set up sine of 72 equals opposite over hypotenuse, multiplying both sides by 110. And I got an approximate safe rescue height of 104.616 feet. And our final example. This one's a little bit more complicated, so I'm going to set up a picture for you and hopefully you can follow along with this picture. So it says at a point 200 feet from the base of a building. So I'm going to draw a building. And at a point 200 feet away, the angle of elevation to the bottom of a smokestack. Well, smokestacks are on top of buildings, so I'm going to assume the smokestack starts here. So this is a 35-degree angle of elevation. And then it says the angle of elevation to the top of the smokestack. So we're going to draw a little smokestack here from that same point. So this angle of elevation is 53 degrees. And we're looking for just the height of the smokestack. So if we call from the smokestack all the way to the ground X, we can use the triangle with the 53 degrees. And actually that's looking a little bit messy. So let me redraw these two triangles separately and kind of show you what's going on here. So the first triangle to the top of the smokestack is our 53-degree angle. And we're calling that X. If we go back to our original picture, then I am going to call from the bottom of the smokestack to the ground Y. So if we take a look at that picture, X minus Y will give us just the height of the smokestack, so that's what we're looking for. So if I draw that second triangle, this was our 35-degree angle, and that's going to give us our y value. So setting up each of these triangles, my red triangle to the top of the smokestack, forgot to label, they're both at a point 200 feet away from the building. So my red triangle, we're looking for the opposite, and we have the adjacent, so we're going to set up tangent of the angle equals opposite over adjacent. So we're going to multiply both sides by 200 to solve. So 200 times the tangent of 53 is approximately 265.409 feet. Solving our other one for y, this one's to the bottom of the smokestack. Again, we have tangent of 35 equals opposite over adjacent, multiplying both sides by 200. The height of the building itself is about 140.042 feet. And again, as I mentioned before, to find just that smokestack, we're going to subtract those two values. 265.409 minus 140.042 gives us a height for the smokestack of about 125.367 feet. All right, so I've got one you-try problem for you. Try and set this up carefully. Make sure you have a picture that matches the situation, and then use your SOHCAHTOA.